Hey guys, what's up? Eddie Alho here with KissAnalog.com. Now, today we got a review on a power supply, and I've been doing a few of these, so yeah, sorry, I didn't really expect to do another one, but I think this one looks like a really nice contender if you're trying to find a power supply for your bench, something that will do most things you want to do. It's kind of hard to find the perfect power supply, and you end up with, a lot of times like me, with multiple power supplies. I've got these big linear power supplies back there, big heavy beasts, single outputs, lots of watts. Those are really nice, but they are big and heavy. Then I have these switchers, these Kaiweets. They're really nice. They're really inexpensive, and so for what you get, I like them. I like the fact you get watts, amps, and volts. So some nice things about that. And they are higher power. They do put out a little higher voltage, so that's nice. But with all these power supplies, you don't quite, I can't quite get the voltage and the current I want and the dual tracking. These two linears together kind of do what I want, but I have two big power supplies. And they're also used, so as far as recommending power supplies to my viewers, it's kind of hard to recommend them because it might be hard to find them. Now the Xantrex power supplies, they're coming used on the market now. I picked up those. Those are low noise switchers. Those are really nice. But you can control them from the back. I've done a video on that showing how you can turn them on and off. You can do some other things with remote control functions by controlling the ports on the back. So there is some control that way. But this power supply is kind of a combination of several of these. For instance, these tracking power supplies, they're great. I love them. The problem is the power is just not there. Like this Tektronix, it's programmable, which is really great, and it's tracking, but it's only a 100-watt power supply. Each side can put out 20 volts at 2.5 amps, so that's 50 watts per side. It's it doesn't really cover a lot of cases. So I got this one up here, the GW Instech, who, by the way, they actually made this Tektronix, but the GW Instech puts out 30 volts 3 amps, so it's that's a lot better, right? So it's 90 watts per side, so it's almost double what you can get as far as power to this. Not quite, but close. And it is a tracking power supply, which that's really nice. So I've got the programmable one, the tracking one, these linear ones, these switchers, and then I've got these two. Well, this one, we're going to open it up and see some of the advantages of this one, okay? So if you can see from there, it says made in China, high quality instrument. So just like the multimeters, there's Chinese made multimeters that are really inexpensive and maybe on the cheap side, and then there's nice meters. The Kaiweets power supply, it's nice, but it is more basic function. It does have the coarse and fine adjustments on both current and voltage, which that's nice, and it has the 3 displays, which that's nice as well. A little higher noise, which there's ways to get to filter that, and I've shown one way. I'm going to show some more in the coming videos, but this one I'm really curious to see how it falls, because it does cost a little bit more. So here, there's the box in the box. So there we go, iTech high quality instrument, your power test solution. Now I think they're going to send me some more instruments to review. They did provide this for free. That was awesome of them. They're not a sponsor. They're not paying me to do anything. They're not telling me or coaching me on anything. They just asked, hey, we like what you're doing. Do you want to review one of our instruments? I'm like, you bet. So they sent this to me. And it came really fast, which I was kind of actually surprised. I had some other videos that I've got ready to come out, so I wasn't really ready to do another review video this quick, but look at this. So the model is IT6721, iTech. I have the link down below. Really appreciate you using the links. A free way to help support the channel because it doesn't cost you anything extra. Using the link down below, I really appreciate that. And let's see, open and inspect for damage immediately. It's always a good thing to do because I've actually bought things where I've put them on the shelf for a while waiting to do a review or something. By the time I get around to it, I find out there's a problem. It's only happened to me once or twice, but save yourself that trouble. Now, it does look like it comes with the heavier power cord. We'll see what gauge of wire this is. I'm going to bring the camera over and show you a close-up of all this, but I just kind of wanted to, pull it out. But yeah, it's got the kind of 8 carton thing, so I like that because it's recyclable, and they're not spending a lot of money on packaging. The box is recyclable, all that kind of stuff. And I'm going to open this up real quick and I'll tell you what's in it. Alright, so this shows how to find iTech product downloads. It has one of these little things you can scan in, and has a place to enter your model number so you can keep this for your records and make it easy to look up things, I guess. And wow, okay, this is nice. You don't always get a calibration certificate with instruments anymore. It used to be it was more common, but now people like to charge you for that. But yeah, it's cool. So it shows the instruments they use for calibration, and there we go. That's pretty nice. It was calibrated just November last year, so it hasn't been sitting around very long. And there we go. So there we go. Pretty lightweight. Feels like it's less than 10 pounds for sure. Probably, I'm guessing 6 pounds or something like that. But there we go. There's a sticker on here showing that it's never been plugged in, I guess. There is a port here. It looks like an RS-232. It's one of those 9-pin connectors. But I think this is just for factory use. So you guys that like to hook into things and play around, you could probably, maybe we could learn something from someone that does that. But it has an iTech warranty, void if seal is broken, which pretty sure we're going to break that seal. But yeah. The rubber feet, as I said, I'm bringing the camera over. I'm going to show you guys close up of all this. The rubber feet on the bottom are just pretty thin. Not much there. The knob feels good. It feels like a encoder kind of knob. I kind of feel the little indents. Now these jacks here for the banana jacks or the wire, they seem like they're made well. I like those. They're nice color coded. You got your red and black, which I'm glad they put them side by side. So hopefully it'll take these kind of banana jacks that you can make. Yep, sure does. So that's sweet. I wish all power supplies did that. A lot of times, like on Kaiweets, unfortunately, they put the ground in the middle. It's too bad the ground was, I could probably rewire that, move these things around. I wonder if that's possible. You know what? I might do that in another video, because then I think this thing would be close enough. Yeah, look at that. So you know what? I'm going to see if I can do that. That'd be awesome. That'd be another improvement on the Kaiweets. But power on off in front, right next to the jacks. That's nice, so you don't have to reach around and try to feel, the power on switch, which a lot of times they put it back there. And you know what? The reason they do that a lot of times, power comes in here. It's just easy to wire it to a switch and wire it back. Just cheaper and easier. This way they have to run the power up, and you have to do that safely when you bring power up to the front panel, so the switch can turn it on and off, and then run it back down to the back, to the board where you're running your power into your board. So it has an on-off in front, which is awesome. I love that. That's one thing I really love about a power supply, which I have very few that do that, where you can turn on and off the output so that once you set up everything, you can turn it off and then turn it on and see how fast your power pops up, and you don't have to sit there and adjust it every time you bring it up. So I like that. But it is programmable, so it has all these other switches. So let's bring the camera over and take a close look at this thing. Hey, by the way, before I do that, just as a kind of teaser, I got this other package. This is a power supply. I'm going to hook up to this audio amplifier I reviewed not too long ago. This is going to be really sweet. Can you guess what kind of power supply is in there? There we go. We're going to do that in a video coming up very soon. So, alright, let's come back over to the bench.
Okay, I thought I'd take you through the manual real quick. There's a cover, and we're doing 2 pages at a time. So you see the ground symbols, safety ground symbols off to the right. I've talked about those before. That's the earth ground, safety earth ground connection. And right here on the left, you see that graph. This graph right here, this is what I talk about, power curve. So between, like, let's say here's 60 volts, from 60 volts over to about 1.5 amps or a little bit higher, you can go 60 volts all the way across. But then after that, you're going to be over 180 watts, so it drops down. So let's say on the other end, if you're at 5 amps, you can go 5 amps all day long as you stay under 20 volts. That is for the IT6720. So I have the IT6721, which goes up to 8 amps. So the curve that for mine would go out here to 8 amps and just be a little different. But this is what I call the power curve. Some power supplies, you can't get full voltage and full current out. So you have to also know what the wattage of the power supply is. So this is a great example. And here's the programming. We're going to kind of walk through this stuff. Now, by the way, this ad right here and this group, these are the two things I'm not really sure how to use them and exactly what they're for. So if you guys know, let me know. Meanwhile, I'll send an email to ask about this, but for now, I'm just going to do this video. And here's a way you can charge batteries. Okay, because you have a constant current and a constant voltage you can set up so you don't overcurrent or over voltage the battery. And here's the two models of these power supplies right here on the left, and the contact us information over here on the right.
And just in case you're curious, that's what the box looks like up close to the box that was on the inside. Model number again. And the other side. Alright, the power cord's 300 volts, 60 degrees, and it's 3 18 gauge wires. So that should be good for 10 amps. And the plug itself actually states that. And you know, both ends of the power cord have nice tension relief in the cord. And let's see. Yeah, there we go. Yeah, so even on the power cord here, on this end, it talks about 10 amps, and it shows it's UL. So, yeah, it looks like a good cord. Okay, and the power supply itself, there's 5 screws on the side. It's interesting, there's 2 on this side. We'll see what that's about. And on this side, yeah, there's 2 screws underneath that label. So, yeah, that label will become void when we do those screws on that side. And the bottom of the box, these feet are just really pretty thin. They could get rubbed off pretty easy probably, but they do give a little protection so you're not metal on metal. And let's see the back of the box. So we do have the switch here and this little label here to cover up the power cord, which has a fuse replacement in here, so we'll keep track of that. And a fan, of course. And there's that connector for the factory. Alright, and here's the close-up of the screen. I think there's a little plastic thing that peels off here somewhere. So I'll leave it on right now because I think it's showing the label of all these things, but oh, okay, they're still there. I didn't know if those are like fake labels. So there's our buttons that we have, our encoder knob. Yeah, program with arrows A, B, C, D. Lock, setup, save program. That's with shift key. And there's our on-off to turn the output on-off. So that's nice. Then our power switch. with our, these are pretty heavy duty. I like these. Alright, and then when you turn them all the way out, they come out just big enough so you can get down, wrap the wire around the turret, or put a hole, or put the wire down through the hole. So yeah, there we go. And as I mentioned before, it does fit these kind of connectors, which is super nice. Okay, so I have the EEV blog plugged in right down here, and we're going to monitor the voltage and with this too, just to see how close the meter here is to the EEV blog. Okay, let's turn it on. Nice. Oh, I do hear a little fan going on. Kind of was hoping there'd be no fan until heated up, but it is very quiet. My guess is that it's going to get louder as we start pulling power, but let's go ahead and move forward. Okay, I see this little dot on D. I think that's for programming, and I'm guessing these arrows, yeah, move it around. Huh, doesn't go to A though. Goes B, C, D. That's interesting. Okay, we'll have to figure out the programming stuff later, but alright, so for right now, okay, it says off. I think we can turn it on and off with this, and here, let's see what the volt, okay, let's set for 5 volts. You know what? 5.1. Oh, I see. That's the digits, B, C, D. So, okay, got it. So, look at that. It turns on when I'm adjusting, and then goes to 0 when it's waiting for us to apply the output voltage. That's kind of interesting. That's kind of cool. Looks like, I'm hoping the camera picks this up. Okay, I'll turn it on. Okay, they're flash. Okay, 5.10, 5.10. Okay, volts, amps. What was that? Okay, that's how I can set. That's how I can set either the volts or amps. That's interesting. Okay, so I can go full 8 amps, or I can back it off. And I'm wondering if I can move this over to, yeah, so I can adjust the different digits. Okay, cool. Yeah, there we go. I can use that. So just for 1.679 amps. It's pretty nice. I like that. Go back to voltage, set for 5.1. You know what? I want to go 5.15. Let's just see if the resolution. Wow, look at that. That's not too bad, right? 1.14 is what I'm showing, and I'm showing 1.146 or 9 here, so yeah, pretty darn close. This looks like a return function, right? Don't know what that does. Now, let's see if I set, yeah, it's changing. I was wondering if as I change, I have to actually hit enter for it to change output, but no, it's changing as I'm adjusting. So, okay, that's how that works. Now it's constant voltage. We have constant current, over voltage protection, over current protection, lock program, and off. So if I do this, it's off, on. I was just trying to see how fast it looks like it transfers. I guess since there's no load, that's why when I turn it off, it kind of drops down a little bit slower. So we'll have to put a load on this thing. We're going to look at this with the scope too. Okay guys, the other thing I want to show you is you have this programming feature here, and the way that works is you can save 4 different setups, A, B, C, D. Okay, the way you do that is, here, let's just set the voltage to, alright, let's set it for 10 volts. Well heck, let's start at 5 volts, okay? Now I can move this arrow over so I could drop that a little faster. So we set that to 5 volts, and then we're going to set the current to, let's say we're going to set that for, I don't know, here, let me get over here so I can move a little faster. Let's set it for 8 amps max, okay? And then we want to save it in channel A, so we go shift, save, and then see how they're all blinking, and then let's just select A. So you can do that for each of the 4 channels and save settings in all 4. Then once you've done that, then you can go to Program, okay, and you can see there's our setting right there, A. Then it goes to 0, waiting for you to turn it on. Then you can turn it on. And you can turn it on right from there, which is really cool because you can just do a step from 0 volts to 5 volts on your test. So you can test whatever product that way. That's kind of cool. Then the other thing you can do is, okay, let's say you go to B, 6 volts, 6 amps. So turn that on. And then I get the step there. Okay, so you can turn on and off in any one of these things. So let's go to C, 26 volts, 7 amps. And, oh, I forgot what that was. Okay, hit C again, and it shows me. Okay, then hit it on. Jumps on. Turn off. Now you can see how fast it turns on too, by the way, right? So, here, let me go to D, show you that, and then turn that one on. Okay, so it looks like C and D are set up very similar. So let's just change D for 60 volts. Take it out of program mode, and let's go to voltage. Okay, let's come over to this digit here. Let's go up to 60, 61, okay? And we'll just leave the current where it is, and we'll say Shift Save. And we're going to put that in D. Okay, that's 180 watts. That's maxed out on D. Now our load, it's only 4 ohms, so it's going to overcurrent. Okay, let's go to program mode. Okay, now let's turn it on. Okay, now our output only jumped up to 12 volts because, see, constant current. It's showing that we're in constant current because, you know, we can't, our 4 ohm load won't let us go there. So we're kind of stopped there. So that's cool. Let me go down to C. I can step right down to C. And 26, there we go. That's about maxed out for the 4 ohm load. Okay, and then I can go to A and B. So that's pretty neat, huh? Now let me single trigger the scope. Okay, single triggered. Now let's go back to, I forget which one we were, A? Let's go to B. So there we go. We stepped from one voltage level to the next level, so you can test power supplies that way. Let's say we're at 5 volts here or 6 volts, and we want to go from 6 to 26. So you can step it like that. And then here, let me trigger again, and then we can turn it off and capture the turn off too. So really cool system here. And there's another thing. You can set up your overvoltage and overcurrent protection. So let me show you how to do that. You hit shift, hit setup, hold it down. This is one where you actually have to hold it down. And then you got your OVP. So you can set that up for some kind of voltage. Like let's say that you want to set it up for 5 volt or 5.5 volts, or maybe 12 and a half if you're charging batteries or something. So you can set that thing up. I'm going to leave it there for now. And then overcurrent protection. Maybe you're testing a new circuit, you don't want to go over 1 amp, so you can set that for 1 amp, you know, and it'll protect your circuit. So power on, when you power it on, if you had this in the on position, when you power it off, it'll power on in the off position. But if you want to power on down here with this in the on position, with it on, then you can turn this here and hit enter. I don't like it that way. I don't think that's, you know, for me that's not a safe way. I like to hit this, turn on and off the load and control it that way. I don't want to power on and have it come up, but you can do that if you want. Beep on, you can turn it off. I like the beep right now, so I'm going to leave it on. Okay, and then you can add, I think up to, I don't know how many settings, 60 settings maybe. I'm not sure exactly how that works actually, guys. I haven't played with that yet. And then the group is the same kind of thing. You can add some groups. And yeah, the settings and group, yeah, I'm not sure about those two things. I have to look into that. And then we're back to where we started. So the most important thing probably for a lot of people would be OVP and OCP. But yeah, those other things are there. And sorry, I looked into that group thing and that, and I wasn't sure. Yeah, I wasn't sure what that meant. Not sure how to work that. All right, so I've taken the screws out, and I took off the sticker on this side. Okay, so let's go ahead and open it up. All right, let's start off the back of the board. There's no components. There is a silk screen outline here, and it says high voltage here, high voltage here. So that's where, and look at all the slots in the board. So that's where the AC power comes in. They're trying to keep isolation. Over here you can see some tabs here. I think on the other side we're going to see some large parts mounted, some surface mount. So they're trying to suck, they're using the board as a heat sink. They're trying to suck the heat out. And then over here there's a masking removed, probably in a few places. You can see these mounting screws, kind of elastic on them to keep them from backing out. Large via fields around the board in different areas. That's also to help carry current and to transfer heat. Alright, let's flip over to the other side of the box. Alright, so here we are in the bottom, the front panel up here, the back panel back here. Alright guys, let's start on this side of the power supply. Let's kind of go through the flow. Let's see how things are flowing through. Let's identify the major parts of the circuit, and then we'll zoom in on certain parts, okay? So what we see is the input power coming in right here. We got this green big old safety ground wire coming right down to the bottom connection here. And then there's another connection going over there, and that's going right down to the board there. You see those capacitors? Those are safety caps. Those are white caps. Those are going to chassis. And then we have another green wire coming up and going back here. And that looks like it's going to this connector. So everything is all tied to chassis. And then let's stay on the green wire thing for a minute, because I see two more over here tied to the chassis. One of them comes up back to this board again. And alright, it looks like the reason why is because there's some capacitors that are going to the chassis. So we have some filtering going on the secondary side, because this is towards the output, so I'm sure this is on the secondary side. Alright, and then there's one more green wire going to our connection right here. So that looks like all the safety grounds. Alright, so then the red and black come through, and look at that. Goes through a nice green choke with, it looks like 3 turns, and then it goes right here. And then from here, part of it's going to go to this connector, because I can tell this connector, these wires are going back and forth up here to the front panel to our power switch. So that goes back here. And then we have these wires, because these wires are coming up to this transformer. And this transformer sure looks like a linear transformer. We have some wires coming off, going back to this connector here. And so what it looks like is we have AC power coming in, we have a linear transformer going to some a power supply circuitry right here. So this is a linear power supply, and that's probably powering all these op amps. I'm guessing these are all op amps, bunch of circuitry for current voltage control. Since this is a power supply, we're trying to control the current voltage, right? The other thing I can see right here, underneath all these connectors, let me move up out of the way, the cables. Right down in there you can see the EMI filter. Alright, see the comm mode choke in the middle, and a film cap there, and a film cap there, those 2 black boxes. And you see those little black disc things down here. Those little black discs down there look like NTCs. That little blue guy down there, and this blue guy over here looks like MOVs. And those 2 little light blue ones on the other side of that black X capacitor are two Y capacitors for EMI. So that's your EMI filter. So then it comes out and it goes through the bridge rectifier, and it looks like there's two in parallel. And then we have our bulk capacitors. So this is a linear power supply, bridge rectifiers, bulk capacitors. And then this is our switching power supply, this section here. This is our switching transformer. That must be our switching FET on that heat sink right there, this black heat sink. That must be for current sense, this white resistor, that big tall white ceramic resistor. Then we have some film caps down there for some filtering. And our fan. On the other side, on the output side of the switching transformer, we have an inductor down there. See that round thing? That's a drum core. And then you can see some bulk capacitors hiding down there. There's two of them. The other one's kind of hard to see, but you can see one of them. It looks like 820 microfarads, 100 volt. So that's for the secondary side of our switcher. And then right there mounted on the bottom of the box, it looks like the output diode with the metal thing holding it down for heat sinking. Yeah, that'd be this guy right down here I'm talking about. Alright, so then coming back to the switching section, it looks like it goes there underneath this linear transformer. And then that's our output section over here. Let me get a flashlight. There's a bulk capacitor. There's another combo choke. And that green one right there, that green coil, that's an air core coil inductor. So that's for high frequency filtering for our output. The sweet thing about that is it will not change with current because the air doesn't saturate like a core would be. But on the other side, it's for high frequency because you don't get a lot of inductance. So, but that's a nice touch. And then that big diode there, I'm pretty sure that's for reverse voltage protection. And then from there, we go this connector right here. So then we go to our output connector, and look, we have another choke, and we wrap it around a couple of times. The way it's wrapped, it looks like it's wrapped for common mode filtering. And then we go to our output board, and look, there's two big bulk capacitors. Alright, if we look down here, we see our two big bulk capacitors, and we see some film capacitors on that board. And so yeah, that's our output. Alright, and then for this linear transformer going out to this section, I can see two bridge rectifiers right there, surface mount, and then these bulk capacitors. So that's a linear power supply again. And then right here, let's see if we come up close. Okay, the little one on the left, that looks like a negative 12 volt regulator. The one on the right looks like a plus 12 volt regulator. Then up here, it looks like we have a plus 5 volt regulator. And then on this side, yeah, it's a transistor there. I think that's a TIP41. So that's our linear power supply. And you know what? I think that this is the fan power connector. So this transistor right here might be regulating the voltage to the fan. Might be turning it on and off is what it's doing, because that goes up to the fan up here. So it looks like that linear power supply with all these linear regulators are powering up all these op amps. Yeah, it looks like that linear regulator must be powering up all this op amp circuitry down here for voltage and current control. Alright, I was trying to find the control chip what's running the switching FET down here, but I looked up close, and that's actually an integrated part with the control chip and the FET built in. It's for a flyback converter. It's from ON Semiconductor. It's a CQ 1565R. So pretty cool chip, all integrated, flyback. So one thing I'd like to point out about the thermal design is the fans here blowing against this current sense resistor on the primary side, and then our switching transformer, and then our linear transformer, and also the output inductors for our switching transformer and the bulk capacitors and so on. But it's blowing across this heat sink where our switching device is, and then across his heat sink with all those fins. It's blowing through those fins, so it's all channeled this way. It's pretty nice design, I think. And then it comes out this side, blows against our output components to keep everything cool, and finally against our output side, and our fans, or the exit vents are right here, so it's going to want to pull air all the way across this way and out those exit vents. So yeah, I think it's pretty nice thermal design. Hey guys, so what do you think? Hey, first of all, I'd like to thank iTech for sending this out to me for free to review. That's really awesome of them. I'm glad they found me and contacted me because I'm really impressed with this power supply. Super low noise. Now, there was that one spike that I saw, right? It didn't happen very often. I think it's a 60 hertz spike. I just happened to go around and touch a bunch of contacts on different things here, like on different power supplies and some of the other instruments. And I think it's just a 60 hertz noise that's coming through. So when I look at the spectrum, I just hooked up to the spectrum. Videos kind of get long, so, but yeah, I should compare all these power supplies. I did do some of that with the Xantrex review. That power supply that's supposed to be low noise. This guy, right now when I turn it on, 60 volts, I don't see any spikes popping up at all. I mean, this thing, from that spectrum, looks like a linear power supply. So, I don't know if because there's no current on it, but on the other power supplies, doesn't matter whether I have current or not, I see some noise, and it changes a little bit with load. But, man, this guy is ultra low noise. Very, very nice. Really impressed. Now, these guys are not inexpensive. They're inexpensive compared to the brand name stuff, but this thing I think is $350. I'll put the price below. I'll put a link below. Appreciate using those links. Doesn't cost you anything extra. Helps me. Helps the channel. Helps support the channel for free. Also, just watching the videos helps. So appreciate you guys and commenting and all that kind of stuff. And want to give 2 thumbs up to patrons while I'm here. So I really appreciate you guys. Yeah, so you know what? I went around to the Xantrex and to the Kaiweets, and you know, I see some spikes when I turn them on, and you know, all you have to do is crank up some voltage without any load on, and just by bringing the voltage up, you see the noise come up, and that's kind of what I've seen before in the other reviews. But this guy here, man, I'll try to zoom in on the camera there just real quick, see if you can see that, but it's flat. See, there's with the load. Oh, that's with it off. Bounces, comes back up, nothing. Looks the same. So that's incredible. Yeah, there we go. Well, thanks for watching, guys, and I got the next video coming up with the Class D amp with the new power supply. That's gonna be kind of cool, I think. So see you next time.